Hello everybody, today we're doing Pacific Atlantic water flow. There is a m times n rectangular island that borders both the Pacific Ocean and the Atlantic Ocean. The Pacific Ocean touches the island's left and top edge, and the Atlantic Ocean touches the island's bottom right edge. So as you can see, the Pacific Ocean touches this island on the left top edge, this point, and the Atlantic Ocean touches the bottom edge. Okay, so the island is partitioned into a grid of square cells. You are given an m times n integer matrix of heights, where h of r to nc, row and column, represents the height above sea level of the cell at coordinate r and c. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any adjacent cell to an ocean into the ocean. So that means that if we have water here at 1, it can flow into Pacific Ocean. If we have some item here, it can flow into the Pacific Ocean and the Atlantic Ocean. Return a 2D list of grid coordinates result, where result I is equal to result I and C of I, denoting the rainwater can flow from the cell R and C to both the Pacific and Atlantic Ocean. So we have several heights here. Let's check it out. And we're going to determine how these heights are able to transport us into certain heights. I mean, from the land into the ocean. Let's say it rains on this piece of island here, 7, right? What happens is that 7 can flow down to 6 and can flow down to 5. And 5 touches both the Pacific and the Atlantic Ocean. So one way we can do this is that we do it the opposite way. We go from the Atlantic Ocean from 5 to 6 to 7, and that would give us the items that can touch this Atlantic Ocean. And we can go look at items from the Pacific Ocean where 5, 6, and 7 can touch the Pacific Ocean. And if they touch both oceans, if these items touch both oceans, if they start from this area and they touch both oceans, then that means that we have visited these items from the Pacific Ocean and from the Atlantic Ocean before. That's possible. So therefore, those would be our coordinates if they are in both sets. So in this other case, we have a 5 here, of course, that touches both. We have a 4 here, and that goes up to 4, and also it goes up. Does it go up to 5? How does it get to 5? I'm not sure exactly how it gets to 5. The 5 here seems pretty sus to me. Because it has no way of reaching the ocean, both oceans, both the Pacific and the Atlantic Ocean. So let's say the 5 goes to the 3, right? Well, it's not going to go up higher, it's just going to go lower into the Atlantic. 5 goes from 3 to 2 to Pacific Ocean. So I guess that's one way it reaches both the Pacific Ocean and the Atlantic Ocean, is that because 5 goes from 5 to 3. Let's check that out. Where is the 3 point? 2 point. 2 point. Yes, that's exactly what I predicted. So or suspected, not predicted. So 2. So this item 2, 5 goes down to 1, 2. So row 1, item 2, 3. and then goes down to 0, 2, and then goes to the Pacific Ocean. And it also goes from 5, 5 to 2, 3 to and this particular point 1, and then to the ocean. So we have to start from every single point of each ocean from each side and go try to touch all the items from that particular point that is equal or higher. So let me write that down just so we remember. Move from each ocean to any node with equal or higher values or heights. With that, we have height of 1 here. This is, I guess, the edge case, being that we could have a height of 0. Of course, a height of 0 touches all the ocean with, I mean, not 0, but if a height, we have one item, it definitely touches all the all sides of the ocean. Okay, that's not much of an edge case. I think we're good to go in terms of our understanding. I think we understand the problem pretty well at this point, and it's time for matching. Match is going to be a recursive call, and it's going to be a graph problem because what we're looking at is two sets of coordinates that union. So it is a union between two sets of coordinates. So what we're gonna do is the plan is get two sets of coordinates and return the union. And how are we going to get the two sets of coordinates? We will use a loop to start from each ocean and run a recursive method, DFS, depth first search, to any item that is less than, or it is equal to, equal or greater than the previous height. And we will add this item, this coordinate, to our Pacific or Atlantic visited set. So it determines if we can visit these items from the Pacific or from the Atlantic set. And that should be all, and then we will be able to return the union of the two. So I think we're good with our plan. Let's try to implement it and see what we're missing. So first things first, we need the Atlantic and the Pacific. So Atlantic and Pacific equals a set and a set. Yes. So we also need to define a DFS call. And what do we need from our DFS call? We need, let's say, a row, a column. Okay. We also need our visited. So that's a set of, like, set, maybe, like that. I'm not sure, maybe. It's a set of ints. Tuple is a set of coordinates. set of array coordinates, sorry, because we're returning an array of coordinates. Okay, and what else are we looking at? We are looking at the previous height. I think that is inclusive with our DFS call. So if the row is less than 0, or row is greater than the maximum, the length of heights, that means maximum number of rows minus 1, or oh, I need to take a pause. Give me a moment. Okay, I'm back. And so this is the length of height. So that means if it's greater than or equal to the length of height, or greater than the length of height minus 1. I'll just do this, keep it the same, and we'll keep going. So the column cannot be less than 0, or the column cannot be greater than the length of the height of 0, which is one of the columns, minus 1. Let's separate these. We could separate these if we do a parentheses like this, and that way we can be more clear about what we're doing here. So we had a or here, and we have an or here. So it's all like, because the parentheses help signify where does this end and where does it begin. So if it's in the visited, so if it's already in, so we check for the R and the C in visited. So if it's already in, that means we've already done the work and we don't have to do it a second time. Okay, what's the next thing? So it's out of bounds, it is in visited, or it's lower than the next height, so the previous height. So if the height of R and C is less than the previous height. So those are a no-no. We just don't work with that. We don't want to, we just return at this point. So we're not going to go any further. We're going to stop. And that's it, right? So otherwise, we're going to continue. And we're going to do this. So we're going to check the next 4 locations for, let's say, 7. Let's check this side, this side, this side, and this side if they are lower. So DFS. Otherwise, we insert it into visited. So we insert R, so visited, dot add. We're going to add R and C. Perfect. So now we're going to do a DFS of R plus 1, C. We're going to take the same visited, and we're going to take the new height as our previous height. So our current height is going to be R and C. And we're going to repeat this 4 times. So subtract plus 1 minus 1. So those are all the 4 directions. And with that, we are done with our DFS call. We have gone to everything, and we have everything in our visited now. So I believe that fulfills our second item. And now, because we fulfilled that, we have the 2 sets of coordinates, and we're going to return the union. So run DFS of 0, or how we're going to run the DFS And so we're gonna get all of these. We're gonna start here for the Pacific and the Atlantic, and then we're gonna start from here to here for Pacific, and from here to here for Atlantic. So for column in height of 0, range height of 0, we do have to separate these because it's not a perfect square. It's going to be a rectangle. So this is the column, and this is going to be for the Pacific Ocean. So we're looking at all the columns. So Pacific Ocean. So we'll take the first row. So we're going to DFS on the first row. So the row is going to be 0, and the column is going to be C, and the visited is going to be the Pacific Ocean. And lastly, we have our previous height, which is going to be height at this particular location, 0 and C. So now we run that same thing for DFS of the last column right here. The last row. So that's going to be length of height minus 1 at C. Each column is going to be the Atlantic Ocean. And the height is of the length of height minus 1. I think we can do better by signifying this. So first row, last row. And this way we can, I think it's a little bit clearer, but we have to repeat this too many times. So let's put this up above. Although this is going to add 2 lines or code, but it's going to be a little bit clearer for a next reader. And I think that's more important than having more lines of code, because code is not for the computer to read, it is for people to read. So now we have the last row, and we're going to have the column. So with that, we're done with this, and we're going to do the first column, which is equal to 0, and last column, which is equal to length of height 0 minus 1. With that, we can do for R in range of heights for the rows, and we can run the DFS call. DFS call of 0. Basically, where are we? This is getting, I'll clean this up code later. So we're going to do our row, and the column is going to be first column. And what is in the first column? The Pacific Ocean, Pacific. And then what is the height of this item? The height of this item is going to be the first column, the row and the first column. Then we're going to repeat the process, this time with the last column and Atlantic. Now, we have the last column here, and that's going to be the height. So because we start here, it's going to be fine. We could start at in very low height, but I don't think that matters. So that's going to be added, and once all these operations are done, after we ran all the DFS, we're going to return the list of the sets. So Atlantic, and the Pacific. I think we have a problem. So this is spelled Atlantic, and this is Atlantic. Now what? Now do we have a problem? No, and we have no problem here either. So with that, I believe that we have the solution to this problem. Let's find out what we have, because I don't know. We have to review the code and go from there. Okay, first of all, we have an error, and we can't do this. This is not good. So I'm gonna go find out how this is done. And oh, actually, it's a list int probably like that. So let's run that. Okay, great. Now we're missing heights, and this is heights. Okay, let's keep running. Okay, so this is length. This is columns. So it's length of height of 0. I think that's pretty clear. I don't know if we need to fix that. And this is the length of height, which is good. So let's run the code and see if that works out for us. Okay, we have another problem. We have heights here again. That was not done correctly. That's fine. We just have to get that in. Okay. This height business is taking a toll on us. I'm gonna have to pause the video if this is still not working. So, okay, I have unpaused the video. What happened was there were just a lot more S's, and we only had to use the tuples instead of lists. But everything else is the same, and everything works properly. And let's submit and see if we mess up somewhere. We don't know if we messed it up, but we did it. Hey, that's great. The solution's not too fast, but we have solved the problem. Let's check out the evaluate the space-time complexity. So the time that we spent on this is O of n times n, like we predicted, n squared. And basically, the space is also O of n squared. So why is that? Why is it O of n squared and O of n squared? Let's take a look again. So the reason why we predicted that, oh, I'm pretty sure we didn't predict that. My bad. So let's find out why it's O of n squared. The reason being if like it's maybe m times n because we visit every single item. So m times n. So it's m times n. So not n squared. I meant m times n because the height and the length of this rectangle basically, and the space is going to be basically m times n because we have to return every single part of this grid. So that's the space-time complexity. So m for height, for number of rows, num rows, and n for num columns. Same here for space. We're gonna need all that space in our sets and our lists. So that's all with this problem. If you enjoyed this problem, like and subscribe. If you have, any comments, like any way we can help improve this code for better readability, please let me know, and I'll be happy to make those changes. One change I can make is like that, and we can move that or into place. Other than that, I think these lines are pretty self-explanatory about what they're doing. I think most people who've seen this code would understand what we're doing here. Comments, let's see. I think this would be a good comment here. and this would be a pretty good comment here to say what we're doing with the recursion. So it's just what our plan was. I think this would be better if we put it in the loop section right here. It's a bit long, but I think it's pretty okay. And then we can go into our DFS. And so we'll just move that DFS like right here. And this will say loop through starting from each ocean. So I think these variables here do help, though they make things look a little bit more complicated than it actually is. So instead of first row, we could say Pacific Ocean row, Pacific row, and Atlantic row. I think that way, I think people like it's more descriptive, and people know exactly why we have these. So so I think that's helpful. We're looking at the Pacific row, and the same here. We do the 0 column, which is like this column here, and we're doing every row for that column. So first column is here, and we're gonna do every row for that. So that's Pacific. So Pacific column, and this is going to be the Atlantic column over here, and that's the Pacific row here and the Atlantic row here. So I think that's a little bit more clear. So let me put that in. Oh, I have a phone call. Give me a moment. Let me get this done. I'll answer a phone call. Okay, so after that pause, I think we cleaned up this code a little bit. So we were trying to do the Pacific and the first column. So that's going to be Pacific column, and this is going to be Atlantic column. Maybe we'll come back next time and read the code, and it'll make less sense, and we'll have to restructure our code so that it makes more sense next time. But for now, this is how it reads, and this is our code. It works, and we'll be back when we see it again. So I hope you enjoyed this video. Like and subscribe, and I'll see you in the next one. Thank you. Bye.